In this video, we'll look at solving a three-dimensional trigonometry problem. Now, this question comes right out of your textbook. It's from page 332, and it's question 3b. Solving a 3D trig problem is a lot like just solving two triangles that are attached, but if you can get perspective, this one's kind of on the ground, and this one's maybe standing up against a wall. And the word problem isn't important here. It's not even a word problem in your textbook. It's just a diagram. But just understand that what you're really doing is solving adjacent triangles. The only difference is it's sometimes tricky to have perspective. Most notably right here in this triangle BDC, this and this have this symbol which means equal length. So the first thing to note is that this is also 15 centimeters. Now you got to know what to solve with. Well, take a look. It's not a right angle triangle, so that rules out SOHCAHTOA or Pythagorean theorem, can't be those. And more importantly, I've got side, angle, side, and the angles between them. That's a classic setup for cosine law. I'm going to write down cosine law. This is D here. And anytime, if you want with me, you can change the letters and re-letter them. And I'm going to work with D squared equals B squared plus C squared minus 2BC cosine of D. That's cosine law. It's just this side squared equals the other two sides squared added together. Take away 2 times these same letters, cosine of the capital letter of this. That's cosine law. Now we're just subbing in to solve for this side right here. I'll call that baby D, so you can see what we're solving for. So D squared equals, both of these are 15, so that's 15 squared plus 15 squared minus 2 times 15 times 15 cosine of, that's a 70 degree in there. So D squared equals, and we'll start to do some work here. Make sure your calculator's in degrees, minus 15 squared plus 15 squared was 450 minus, and now 2 times 15 times 15 times cosine of 70, which is, I think I typed that wrong, 450 doesn't sound right. 2 times 15 times 15 times cos of 70. I was expecting a crazy decimal. There we go. So minus, please keep all the decimals unless you don't want full marks. 153.9090645. And now D squared equals that, take away that. I guess I could have left that on my calculator. Oh well. I'll just type it in. 450 minus 153.0909. Oh, that doesn't look right. 153 point, I'm having trouble with my numbers today. 153.9090645, which equals 296.0909355. Now notice I don't have D yet, I just have D squared. And if this is seeming confusing, please watch the videos on cosine law, as I'm going fast through this part here, assuming you know cosine law. How do you undo a square? Square root both sides. And so you get D equals, I gotta retype that so I can put the square root in front. What's the square root of 296.0909355? The answer is 17.207. And my units are centimeters. Now I'm not quite done. I just have this here, and if I haven't mentioned before, we're trying to solve for this x. But before we do that, just check me on my communication here. You should put a rounding dot on any line you rounded on, or the calculator rounded on. I rounded at the end here. That needs a rounding dot. And also I rounded on this line, well, my calculator rounded on this line right here. So I'm going to move this 2 over. It should not be over the equal sign. That's a communication error. Is D squared. And on top of the equal sign, a rounding dot. Rounding dot where you or the calculator rounded. I'm going to continue over here. I've got this side of this triangle here. I used cosine law to find this bottom side here, and now I can solve for x. I'm in a right angle triangle. That means I'm going to use SOHCAHTOA. I'm working with this side, which is the opposite of 27. can label that up. And I'm working with this side, which is the hypotenuse. Think about the acronym SOHCAHTOA. What formula uses opposite over hypotenuse? The answer is sine. Always start with your formula. Sine of theta equals opposite over hypotenuse. Make sure my fraction goes the whole way there. So the sine of 27 degrees equals opposite, which I just solved for was 17.207, over hypotenuse, which is what I'm solving for, x. Notice no rounding dot here. I'm not rounding here. It's the exact thing I got here. I already showed I rounded here. On this line, I didn't do any more rounding. What I have to do is solve for x, but x is on the bottom. There's a video on this too, if you're not sure what I'm doing here. I'm solving for x when there's, I think it's called trigonometry, when the denominator is x. So let's times both sides by x to get the x out of there. And on the left-hand side, I get x times the sine of 27 degrees. And on the right-hand side, 17.207. That degree symbol's optional. Don't have to put it, but you can put it. What I want to do now is get x by itself is x times sine 27. What's the opposite of times? Divide. So I divide both sides by sine 27. And when, look, I left out my degrees. And when I do that, I get x equals, I know I'm going to round here, so I put a rounding dot because I don't want to forget. 17.207 divided by sine 27. Let's round to the nearest 3 decimals, because that's what I typically put on tests. And you get 37.902. Don't forget your units, centimeters. And we found it. We solved a 3D trig problem. We used cosine law at first, solved for one of the sides, and that allowed us to use SOHCAHTOA, in particular sine, to solve for the x value we wanted. So that's solving a 3D trig problem.